In this lesson, we're going to summarize the ideas we learned in the investigation. If you haven't tried the investigation, I would print that off first, just because we're going to take the ideas from that and use them for the next couple of days worth of activities. So the big idea too is a sinusoidal function. Anything that contains a sine or a cos in it, so y equals sine x or y equals cos x.
Mr. Cavisto, contact the office, please. Mr. Cavisto, contact the office.
Is considered periodic. We just call them sinusoidal curves. Don't get confused with the words sinusoidal and sine. They mean two different things. We learned some big properties that we should know about. Property number one, the amplitude. Both sine and cos have an amplitude of 1 if they're in standard form. And standard form is just y equals cos x or y equals sine x. Both of these have a period of 360. That means they repeat every 360 degrees. They both have a equation of an axis of y equals 0. The central axis is right in the middle of the graph, the x-axis. They both have a range of -1 to +1, so they go as high as 1 and they go as low as -1. That's where they go, depending on which one's which. And their domain's all real numbers. These things keep repeating over and over again forever and ever in both directions. So I can go up and down and up, or down and up and down, and they're going to keep on going. Okay. These functions have parent tables, like they did for the functions we did earlier in the course. Our parent functions are related to each other in that they have the same x values, but the y values are different from each other. A sine curve, and we want to memorize this 5-point table if you can. Okay, starts off with a 0, 1, 0, -1, and 0. And our x's always go up from 0 by 90s. Same is true for the cosine, except for its table, we'll start at 1 in the y values, back to 0, -1, 0, 1. So the picture looks like this, and the sine one goes up and down and back up again. Okay, now these functions are actually related to each other. If you think about this, I could continue on this graph, and then my cos curve would fit right on top of it. Okay, we talked about that being a relation between a sine and cos. We can transform these functions like we do any other functions because they pass the vertical line test. So some common things we should remember. A, the number up front, is our vertical stretch or compress or reflect. But the nice thing is A also stands for amplitude. Whatever number is out there is your amplitude, which is why in standard form we have an amplitude of 1 because the number in front is a 1. And also nice, the K is your horizontal stretch or compress. When you change your horizontal length of something, you're changing the period. So the nice thing here is we can take the K value and take 360 divided by K, and that will always give you your period. Which again, go back to standard form here. Our K value is 1 right here. So 360 divided by 1 comes out to 360. That's why the period is always 360 for these functions. And the other nice thing, the thing at the end is our C value, which stands for our central axis. And that's our vertical shift up and down. Again, back to our standard form, we set our standard equation as y equals 0 because there is no number here. So it hasn't been shifted up or down, so our central axis is 0. Hey, we're just going to try one little question here to get some ideas of how we can use this stuff to get shapes, graphs, functions based on some properties. So I want to write the equation and sketch the sinusoidal graph that has the following properties. It has a period of 6. Well, I know that period and 360 over k are related to each other. So if I'm told the period is 6, I can take 360 over k and solve that. So if I cross multiply, I get 6 times k equals 360, or in other words, 360 over 6 is k, and k is 60. I know that my amplitude is kind of handy. That gives me an a value of 4. And central axis is my c value, so c value of -1. So I can make myself an equation. Y equals a, 4. Sinusoidal, so my choice is sine or cos. I'm going to pick sine right now. I could choose either one. My k value is 60. There's my x, and my c value is -1. There's my equation, a, k, and c. We're also asked to graph something, 2 cycles of a graph, in fact. So we need a set of axes. The nice thing about sketching periodic functions is once you know one cycle, you know the second cycle. We're told the period was 6. That means every 6 units, it repeats. So I'm going to make my graph in sets of 6. I was told my central axis is -1. So at -1, I have the average of this graph, the middle of this graph. I was also told the amplitude was 4. That means they never get higher or lower than 4 from the central axis. Now here's the graphing part we have to think about. Sine curves, if you go back for 1 second here, sine curves start on the central axis. All right, central axis is 0. They end on the central axis, and the middle of them is on the central axis, which makes my life really easy when I want to graph something. Because I know that if I want to graph this curve, I start on the central axis, I end on the central axis, and the halfway point at 3 would be on the central axis. Between those two things, I now go up to the maximum and then down to the minimum. My maximum is 4 units, my amplitude of 4 units above the central axis. So I go up 1, 2, 3, 4, which is number 3, and I get a point. I go down 1, 2, 3, 4, which is number -5, and I get a point. And then I make my curve. And then do the next cycle. Start on the central axis, end on the central axis, middle on the central axis. 1/4 point maximum, 3/4 point minimum. Graph it. There's my 2 cycles. Okay? So just some basic ideas about sinusoidal curves, just means sine curve, cos curve, properties, A, K, and C, and how they're related, and some questions you might want to try today.